Hello, and welcome to Hocking College Lab 1102. This is week 6, first day. Um, First day after the midterm exam, which most, but not quite all of you have taken. Um, so let's start with some administrative things. Again, I just want to remind you all that it is not too late to get any attendance or to get marked for attendance or to get participation credit or to turn in your homework. There are no late penalties for any of it. I do have the homework set for unlimited attempts. Um, I need to do a better job of verifying that there are no second attempts I need to grade still. It's and there's a couple of emails I need to go back through to double check what people have told me they've done. Um, a couple of you have submitted things in odd formats or in the wrong place or done the wrong problem. And I've put notes in the homework regarding that. So if it's was turned in a while ago and not graded, or if you got a 0 when you didn't think you deserved it, look at the notes. I've also provided guidance on what you should be doing in those. Yeah. So moving on. Um, the first lab is visible to students now. I thought I made it visible last week when I made it, and apparently didn't. I forgot to grab the apparatus to show you right now, so you'll have to watch the recorded lecture session from tonight to catch that. Um, but let's move on to the new material. Today we're talking mostly about sampling. Um, Sampling is honestly, in my opinion, probably the step in your analysis that has the biggest possible impact on your results in terms of quality. Uh, if you mess up sampling, you're likely to get garbage. If you didn't prepare your sample right, you got garbage. If you didn't store it right, you got garbage. If you sampled in such a way that it's not representative, you got granted it might not be complete garbage, but it's really hard to tell. So it's remarkably easy to end up with garbage. You screw up sampling, you've quite likely screwed up. Um, Thankfully, it's not actually that hard to get right or right enough. But it's also remarkably easy to get wrong. So when you're figuring out sampling, there's some considerations. There's where to take your samples, what type of samples they're going to be, what size of samples, how many samples, and is there anything you can do with sampling to minimize the overall variation and increase your precision. Um, I should mention here that as far as I can tell, there seem to be kind of two branches for where you can go with cannabis testing. Um, One is sort of the official testing lab route, such as what there is at Hocking College. Um, it's doing regulatory type testing. Um, if somebody needs to send a sample somewhere to be tested, things like that. The other way, and I don't know how big this is going to be, but I can easily imagine that processing facilities are going to end up needing some internal quality control type testing. Testing product coming in, testing it at the operators are going to need to run various tests depending on how they're processing it and what the process is. There may be places in where you want to test to make sure that things are on track as you're producing it. Um, Different types of tests, and then tests of your final product quality uh, that are going to need to be done so you can know that it's safe to sell, safe for consumption, that it's the strength you say it is. Things like that. That some of that is going to need to be internal as well as being sent off to a lab. Um, my background is in industry was at a plant where we had a fair amount of internal testing and a lot of things. So I'm familiar with that side of things and what that can look like. Um, Probably on a larger scale than what you're likely to see in the cannabis industry for a while, but still that's where I'm coming from and where I tend to think of in terms of sampling. Um, Another place where sampling comes into effect is research. If you're, but I don't, researchers are likely to have graduate students to do their sample collection and run their samples, so that's likely to be less something you're less likely to be involved in. The other side of things is of course the labs like the commercial labs like they have at Hocking College where somebody is sent in a sample and asked to have it analyzed. You're doing things for uh, it might be quality control to make sure that you know maybe every so often the internal lab needs to send something to an external thing to make sure it's standardized. Maybe you're looking for something that the internal lab can't look for, things like that. So there's a slightly different perspectives in terms of sampling. Um, but back to the slides here. Um, so we consider things like where to sample. So if say we've got a semi-load of buds coming in, let's say that things take off, it's legal everywhere. Farmers are shipping it around by the semi truckload. So you got a semi load of buds coming in. Where are you going to sample that to make sure you've got a representative sample so that you know what the quality is coming in? So you know that there's not mold somewhere in the middle of it. So you know they didn't stack all the good stuff by the door, and by the time you get to the back, it's no good. How much, you know, are you going to sample? Well, we'll talk a little bit about some other things on what type of sample, but are you going to sample the gases around the in the container? Um, Check the humidity there to see oh, to see if that's likely to have caused mold, or you're going to sample the plants. That's one one example of what type. You know, how much to sample? How many samples do you need to make sure you've got something representative of this semi load? Um, those are all things you need to think about when you're deciding how to sample something. Um, so some other concepts in here is your populate. So sample is what you're pulling out. Population is the whole thing. So if we were testing the population, we would somehow test that entire semi truckload. That's not feasible, so we're sampling we're doing a sample of the whole population. Um, Population could be homogeneous, so everything in it is the same, it doesn't change, or it could be heterogeneous, which means it's not the same, it's going to change with position, it's going to change with time. If we leave everything sitting in the shipping container for a month, is that going to be the same quality that it was when it arrived? If it's not, then it's heterogeneous with time. If it is going to stay the same, then it's homogeneous with time. Can we reasonably expect that nothing is going to change with position in that shipping container? Now, since pretty much we can almost there's not too many things where we can guarantee that things are going to be homogeneous, especially when we're dealing with biological species. Back at the pulp mill, because I've always got to tell stories about back at the pulp mill, we had a client who, when they were doing their first run, they wanted wood chips that were only from the underside of branches grown on the north side of the tree, and because the fibers were a little bit different depending on where in the tree they were. Um, trees growing next to each other are a little bit different. Biological systems have a tremendous amount of variation. You've got to look at them kind of in aggregate, but there's a lot of heterogeneity in there. So you're not likely to be able to have a homogeneous sample very often. Um, in terms of how to sample, how to pick where to sample, you can do it randomly. You can decide I need however many samples I need, and I'm just gonna assign a number to different locations and let a random number generator decide which ones I do. And you may or may not get good samples from that. You might end up getting a little cluster, because if it's truly random, and getting a little cluster and sampling from all over is somewhat likely. You can do a judgmental sampling, so you can use prior information to guide it. So you could say, I know that the stuff in the center is probably the most likely to be moldy, so that's where I'm going to sample. Um, you could do it systematic, so at every 3 feet or 4 feet throughout the thing, I'm gonna pull a sample. Um, you can do a combination, systematic and judgmental. So I like the example they have in the book here. They're talking about a water pollution thing. So if you've got an underground storage tank and you know a little bit about the groundwater flows, it doesn't make a whole lot of sense to test upstream, but you probably still want one or two upstream, and then you'll have more clusters of testing downstream, but it's still going to be at somewhat regular intervals instead of just all your testing being downstream. There'll be a little bit around, so you kind of get a good picture of things. Stratified is another combination of systematic and judgmental with different considerations going into it. The last thing is convenient sampling. That's you get the sample that's easiest to get. It's what you can get. It's what you've got. It'd be like all you can do is open the door in the semi and reach in as far as you can maybe, and that's what you've got. That's your convenient sample. Um, so types of sample, there's in addition to gas or solid or liquid, things like that, you can do a grab sample, which is got there we go. I've grabbed my sample. That's from the middle. That's one sample. There's a grab from another spot. There's a grab from another spot, and you got those. One of the things you can do is take those grab samples and mix them all up and create a composite sample. It's a mixture of all the grab samples, and you kind of build in an average that way. Um, there's also in situ, so the on-site in situ basically means on site. It's frequently some form of continuous sampling. You've got a probe somewhere that's giving you a constant readout of the moisture content in the soil, maybe um, something like that. Sample size considerations with that. Too small and it might not be representative. If I only grab an ounce for my whole semi load, that maybe that's not enough to tell me much. Um, if it's too large, then it's going to be a lot more time consuming to process and analyze. It's also going to be a lot more expensive, both in terms of wasted product. Anything I pull out for sampling, I'm probably I would hope I'm not going to sell or use later. Um, it's going to take a lot more reagents to process. If I've got to dissolve it in nitric acid to test for metals, then it's going to take a lot more acid to do a larger sample. Um, my equipment, modern equipment doesn't really need that large a sample, so it's going to take a lot more time to run the number of samples for that to get something from that large amount. Um, those are things to consider. So you don't want to be too large or too small, and what the medium is really depends on the test. If you're doing bulk density measurements, then a larger sample is fine, and that one you probably can throw back in. You're just measuring the mass that's in some volume. If you're doing there's a few different ways to do density measurements for something like, for plant matter. You can either just, fill some volume with it and measure it, maybe with some set amount of compacting, or you can fill some volume and then fill it with water and make sure that it's fully saturated so you don't have any air or anything in it, and then measure that. And you get slightly different numbers, or maybe more than slightly different. So density measurements done that way, you probably would have to throw that sample out. But they're needed for different reasons. How many samples to take? There are some lovely statistics and calculations you can do in section 7.2 that goes through that will let you calculate the minimum number of samples for some desired level of accuracy and variance. So that's all there nicely in the textbook. Um, last thing wanted to go over from the textbook section was in section 7.3. 7.4 is really an introduction to some other material, and it doesn't, there's nothing in it to go over separately. So once you've got your sample, there's different things you need to do to store and preserve it, and different timelines you need to meet before the sample is gone bad and something has changed, depending on what you're doing. There are some wonderful tables in section 7.3 that go over this to give you kind of a feel for what you do. And again, this varies by what you're testing for and what type of material you're testing. So this was the table for if you're testing natural waters and wastewaters. So if you're testing for chloride content, you don't need to preserve it, and you've got 28 days to run the sample. If you're testing for metals, you need to keep it at about 4 degrees Celsius. So be about refrigerator temperature probably. And you've got 24 hours. For mercury, you add some nitric acid to get the pH down a bit, and you've got, again, 28 days. pH, you don't need to do anything to preserve it, but you need to analyze that immediately. Thankfully, pH is pretty quick and easy usually. So there's a similar table for gases and solids, things like that. So again, if you've got the sample and you don't preserve it, or if the sample is sent to your lab and it's not been preserved, then depending on what you're testing for, there's you may or may not be able to tell anything. So this is a very important concept to have when you're trying to track down problems in your testing. It's definitely something to keep in mind. Was the sample handled, preserved, and was that all done correctly? Is the sample representative? Does it show what I need it to show? Um, Yeah. So in the class, and during class time tonight, I'll go over this again, but we'll also go over some sample problems, um, and I'll talk a bit about homework. I think it was assignment number 6, the question number 1 from chapter 5. Had a few people turn that in, and only one person come close to right. So we'll go over that a bit too, and we'll talk about the lab. So um, hopefully I see you all tonight, and you probably won't watch this till after today anyway. So tonight will just be confusing, but that's okay. Um,